Welcome. In this video, we're going to focus on what a negative exponent means in math. Negative exponents are a way for us to show repeated division for the same base term. We've worked with positive exponents a lot. You could think of negative exponents as being the opposite operation of a positive exponent. If the positive exponents told us to do repeated multiplication, the negative exponents, they're going to tell us to do repeated division. Let's take a look at an example. Here we see the expression 4 to the power of negative 3. 4 is the base term, the exponent's negative 3. That negative exponent says we're going to repeatedly divide with the 4. We're going to divide by the 4 3 times. And we're going to take a look here at how mathematicians realized the negative exponents told us we needed to divide a bunch. Here we see the familiar positive exponent part of the table that we should know already. 4 to the first power, 1 copy of 4 makes 4. 4 squared, 2 copies of 4, 4 times 4 is 16. And as we keep multiplying by another copy of 4, 4 to the third, we go up to 64. Times by another copy of 4, 4 copies of them, we get up to 256. But we should see a bit of a pattern here as we work backwards if we start to think about what does the power of 0 mean and what the negative exponents mean. We see at every spot along the way here, if we work backwards, if we take 1 power of 4 away, we need to divide by 4 because we have 1 less factor of 4 to multiply by. So again, as we go from 16 to 4, what we really did there is, again, we divided by 4. We took 16, we divided it by 4 because there's 1 less 4. So if we go from 4 to the first power to 4 to the power of 0, again, we need to go ahead and divide by 4. And when we do 4 divided by 4, we get to 1. This is what we started to see yesterday. Anything to the power of 0, if we look at the pattern in these exponent tables, by the time we get to the power of 0, when we do 4 divided by 4, it equals 1. It's always going to equal 1 whenever we raise to the power of 0. But now let's think about what these exponents mean. If I need to keep following the pattern, if I need to keep dividing by 4, 1 divided by 4, which is what we're going to be asked to do there, 1 divided by 4 leaves us at 1/4. So that tells me if I have 4 to the power of negative 1, my answer is going to be 1/4. And if I divide by 4 again, if I take 1/4 and I divide by 4 again, 1/4 divided by 4 really means 1/16. And if I divide by 4 one final time, one more time that I divide by 4, 1/16 divided by 4, I get 1/64. That's what we saw over here for 4 to the negative third. If I take 1 and I divide it by 3 copies of 4, I'm really going to have 1/64. So we should see a rule out of this eventually. If I look at 4 to the negative second, it's 1/16. But 4 squared was just 16. So I realize 4 to the negative second is just going to be 1 over whatever 4 squared is. Same with 4 to the negative third. Well, I know 4 to the third is 64. So 4 to the negative third is just going to be 1 divided by that 64.